This is what the lake looks like right now. A month ago, the lake was less green and things were moving in the right direction. Light was getting through, plants were growing, and the transition was unfolding the way I expected. This, however, is now different. You can't see through it. Front to back, completely gone. Whatever's happening in there, I have to infer it because I can't watch it. And the thing I keep coming back to is that this didn't happen because something went wrong. Every decision that led here made sense. Better plant structure, a closed system finally running at full energy. The food web just hasn't caught up yet. So the question isn't really how to fix the algae, it's why the food web keeps breaking at the same place and what it's going to actually take to rebuild it correctly. To understand why the food web looks like this, you have to go back to the plant transition. And the old dominant plant in this lake was Ludwigia, creeping primrose willow. Its root structure was massive, and it lived in the water column. It was pulling nutrients directly out of the water the whole time, and on top of that, it was physically blocking light just through the sheer density of the stems. So you had low available nutrients in the water, low light penetration, and the algae had nothing to work with. The water stayed perfectly clear. When I switched to tape grass and Sagittaria, I was solving a real problem. Ludwigia was monopolizing the system, but both of those plants are substrate rooted. Their roots go straight down into the sand. So now the water column is open. Light reaches everywhere, and all of those nutrients that used to get pulled out are just available. That's a fundamentally different environment, and suspended algae thrives in exactly those conditions. Green water was the expected outcome of that transition. I knew it was coming. But then on March 12th, I replaced a number of burnt out bulbs across the 24 lights running over this system. I wasn't upgrading anything, I was just restoring it to what was already supposed to be. But the effect was pretty significant. The system started receiving the full load it was originally designed for, specifically more than it had been getting, and more light means more fuel for the algae. That's when things went from modestly green to what you're looking at now. The obvious answer is to dial the lights back down, but I'm not going to do that. The system runs on energy. The food web, the plants, every organism here depends on the light input. Throttling the energy to fix the algae would just be solving the symptom by breaking everything else. The answer has to come from inside the food web. So if you can't reduce the light, then what do? The first thing most people reach for with green water is clams. Freshwater clams are filter feeders. They pull suspended particles out of the water column continuously, and they work. I've used them before for many years, and the water does clear. But here's why I don't want to do that again. A clam filters the algae and just locks that energy inside a shell. It's not reproducing at any meaningful scale, it's not becoming prey for anything in the system, it's not feeding the shrimp or the crayfish, it's not moving energy anywhere. It just collects that energy and it ends with the clam. The algae disappears from the water column, but nothing else in the food web gets stronger because of it. It's a mechanical fix that completely bypasses the biology at this scale, and that's not what this system is trying to do. There's also something I said in a video a couple months ago that I need to address directly. Back then I said that Daphnia weren't the answer, that they were already in the system and the flagfish were keeping them down, and the tape grass would eventually create enough shelter for things to balance out on their own. That made sense at the time, but the solution changed, and what I thought would be a slow gradual resolution became something that needed a more deliberate response. Daphnia, the right kind, under the right condition, is actually exactly what I'm trying to build towards now. I'll explain what I mean by all that, but first, the flagfish. The flagfish was here for years. I liked him. Active, interesting to watch, kept certain things in check. He was also breaking the food web at exactly the point I needed it most. The way the system is supposed to work is, algae gets consumed by microcrustaceans, Daphnia, copepod, small organisms that reproduce continuously and live in the water column in large numbers. Those microcrustaceans get consumed by the shrimp and the crayfish, energy moves up in the food web in steps, and that middle layer is where the food web either holds up or it doesn't. For a while, I thought the Ludwigia would change the equation. It grew incredibly dense. I figured that much structure had to offer enough shelter for some population to get a foothold. I carried that same logic into the tape grass transition, but watching the tape grass grow in, I'm starting to think that there may never be enough density here to make that work. One fish hunting every single day is just patient in a way that reproduction can't keep up with. So on April 5th, I caught him and removed him out of the lake biome and moved him into an outdoor tank. He's fine, it's a good retirement, but his absence opens something that's been closed for a really long time. For the first time, the middle of the food web actually has room to exist. The question now was just what exactly to put there. A couple days before I removed the flagfish, I visited my friend Lucas at LRB Aquatics, an aquaculture farm running fish and plants under naturally grown, filter-free conditions. It's a rare setup, and for someone building an ecosystem like miniBIOTA, it's an ideal source because the organisms coming out of there are already adapted to the low intervention environments. I'll link him in the description. So I left with several hundred Daphnia magna and about 6 dozen blackworms, all of them ready to be added to miniBIOTA and see how they'll affect the system. With the flagfish now gone, I introduced them on April 5th. I knew the risk with the Daphnia magna going in. They're on the larger end for this type of organism, and the size was actually the point. A bigger body means more accessible, more efficient meal for the crayfish and the shrimp. If I'm trying to move the energy up the food web, I want something the larger animals can actually capture efficiently. So I put them in and watched. They swam around with a lot of energy, and they were doing fantastic that first day. I was really encouraged by what I was seeing. But by the next morning, they were completely gone. Zero movement in the entire water column. This was obviously a huge disappointment. My best guess is that the water temperature was just too warm for this specific type of creature. As it turns out, Daphnia magna are not a native species to Florida, and because of that, they're used to colder waters from up north. And so when I checked the water temperature, I found that the top half of the water column was at 83.6 degrees and 77 degrees at the bottom. And so these temperatures are just way too warm for this specific species of Daphnia, and I really should have checked that before adding them in. And so after reeling from that loss, I came to understand that what I really needed was Daphnia that are native to Florida. I needed to find local Daphnia if this was actually going to work. The reason I didn't go to this first is because local Daphnia are much smaller than the Daphnia magna that I was really wanting to add. But that's okay because ultimately it's really about bridging this food web, and smaller Daphnia can definitely serve the shrimp, and the shrimp can serve the crayfish. So I went out looking in the waterways near my home. The target was Moina, a smaller, heat-tolerant microcrustacean. I was checking stagnant ponds with algae and leaf litter, the kind of habitats where these things tend to concentrate. I checked several locations and found nothing. Amphipods in some samples, but none of what I was actually after. What I kept finding everywhere was duckweed, and I started collecting it. Duckweed is actually a compelling option. It grows fast, it has high nutritional value, and it shades the surface, which would directly compete with the suspended algae. The logic is there, but duckweed has failed in miniBIOTA before. It needs continuous nitrogen input to sustain itself, and the organisms just eat it faster than it can expand. I've collected some anyway, just to test under certain conditions, but I'm not really convinced it's actually going to be a solution here. And so by the end of the day, I was pretty much disappointed and was finding no luck. But then right there at the end of the trail, I came across a small shallow wetland. I saw the clear water, leaf litter at the bottom, and it was easy to walk past. But I took a small sample as a last hope, and immediately it was alive with all of these organisms that I hadn't seen all day. Hundreds of Daphnia, large ostracods, neither of which have shown up anywhere all day long. The Daphnia appear to be the heat-tolerant native species that I was after, and that's because they came from a warm, shallow, sun-exposed wetland. These are Florida organisms that are living in Florida conditions, the same conditions as the lake. Their success in the lake biome is not guaranteed, but it's definitely the best chance that I have for this to work now. And so everything I found from that wetland went into the lake biome. Along with the Daphnia were the ostracods, which are large-bodied and exactly the kind of high-value prey the crayfish can actually work with. A single small water scorpion, which are predatory but almost certainly going to be eaten before it causes any real trouble. Planaria, which will scavenge but probably get consumed quickly, and 6 leopard ram's horn snails, a genetic morph of the same species already in the lake. Same organism, it just looks a little different. I also added the duckweed I spent all day collecting, but only about 2 tablespoons worth. I didn't want to introduce 2 variables at once and not know exactly which one did what, so the Daphnia go in first, and we'll see where everything goes from there. There was one more thing that I sampled that I almost didn't notice. A predatory flatworm that came in as a hitchhiker. Under magnification, you can already see that there's eggs attached to the flatworm. It preys on small crustaceans, Daphnia, copepods, and ostracods, so it's in direct competition with what I'm trying to establish. And so that's a variable that can turn into a complication that I'm going to be watching closely. And so at this point, the lake is still green, and now the real question is whether these microcrustaceans can actually do the work. Everything else is finally in place. The right plant structure, the energy input is high, no fish picking off the middle of the food web before it can establish itself, and the organisms in the middle came from conditions that actually match what they are being asked to survive in. If the Daphnia hold and the ostracods hold, the food web will run in the way that it's supposed to at this scale. Algae converts to microcrustaceans, microcrustaceans convert to shrimp, and shrimp convert to crayfish. The water, in effect, might start to actually become clear, not through any mechanical intervention, but because the food web finally earned it. That unfortunately is going to take several weeks to find out, but every piece is finally in its place. The algae is the fuel, the Daphnia is the bridge, and even the flatworm itself might just be another step in the food chain. I, of course, will be watching, but how do you think the food web is going to balance out? Do you think this is going to work, and is it going to be sustainable? A couple of things before I go. If you're building a natural system and you're looking for organisms already adapted to low intervention environments, check out Lucas at LRB Aquatics. He runs an aquaculture farm under naturally grown filter-free conditions and is one of the most thoughtful setups I have ever come across. He's an expert doing this for decades and he shares his experience on YouTube. Link is in the description. And thank you to everyone who's been supporting this project on Patreon. Each biome in the system has a sponsor, and their names are physically part of the build, 3D printed and mounted on the cabinet beneath the biomes that they choose. That support is what makes experiments like this possible. If you want to be part of this story, the link is in the description below.